My name is Teis Mikkelsen and I come from the Technical University of Denmark, and today I would like to talk about plant and greenhouse gases, but especially about the new unaccounted plant sources. If you look at a terrestrial surface, it's normally covered with plants, except if you're in a desert, or if you're in a city, or if it's covered with ice. And normally, the vegetation will form a close canopy with many leaves. Normally, you will see leaf layers up to 5 compared to the ground area. And this is very important for the gas exchange. Then you have a factor 5 where you have increased the gas exchange between the ground and the atmosphere. And this is very important, for instance, for CO2 uptake. We have a photosynthesis process going here with a high rate, and we have a almost just as big respiration rate going the other way from the vegetation and the soil. But if you look at the net gain, globally speaking, we will see a little bit that is actually absorbed by the vegetation and the soil over the years. And this means that carbon is taken out of the atmosphere, and this means that plants are helping mitigating the increased greenhouse effect by storing carbon dioxide in the vegetation and in the soil. But there are also other greenhouse gases. We have methane, nitrous oxide, and the indirect greenhouse gas, carbon monoxide. And if you read the literature, it's almost a secret. You're not reading much about them talking about plants. And there are different reasons to that, but now you will hear the story. Speaking about methane, in the year 2006 in the journal Nature, some physicists published an article telling us that plants emitted methane. Actually, they investigated a lot of plants, and they all emitted methane. And they made an upscaling, and they told us that up to 40% of all methane sources in the world came from plants. This was not true. They had made their upscaling without knowing the mechanism behind. But people started looking for a source, not a source, a driver. And the driver was found by several groups that it was solar radiation, including ultraviolet light. So what was the source then? It is not fully discovered yet, but it could be pectin, it could be surface wax, it could be other compounds, but the truth is there's probably a whole lot of compounds, including these here. We still have a lot of variation looking at the methane emission if you look from plant species to plant species. And even if you modify the surface, as we have done here for the brassica, we have removed the wax, as you see here, for the seaside. And for the seaside, when you expose this to UV light, you will see a 5 times higher methane emission from the surface here. So there are still a lot of unknowns to be investigated concerning methane emission. We have used the same techniques as we did for methane for investigating nitrous oxide. And we have a plant chamber over here, and we have a very sensitive instrument here detecting nitrous oxide. And then we connected these 2 units and recirculated the air between. So we had a leaf here exposing it to UV, B light, and then over time we could actually see a build-up of nitrous oxide. We also investigated carbon monoxide, and it's actually not a greenhouse gas because it's not absorbing infrared radiation, but it's an indirect greenhouse gas because it reacts with the hydroxy radical OH, and this is the same for methane. Actually, it reacts with 85% of the methane in the atmosphere, and meaning if carbon monoxide is reacting with the OH instead, less methane will be removed from the atmosphere, and that's why it's an indirect greenhouse gas. It's not a new thing that carbon monoxide comes from plants. It has been known for many years, and actually it was in the third assessment report for the IPCC panel. But it was later removed from it. We actually don't know why, but we have an idea. The results published so far was based on a lab experiment. So we think we have to go into the field to do the measurements. And we did that. Actually, we did not went very far. We just went outside the lab window here, where we have our plant chamber here. But it was a very important step, because by doing that we could expose the leaves in the chamber to natural sunlight, and thereby we could make a more realistic upscaling. We also have some other field measurements. We have chambers with UV transparent surface, so we could quantify the gas emissions due to ultraviolet light. And we made an upscaling for the nitrogen oxide. Due to UV, we have estimated 7 to 24% of all natural terrestrial sources to be driven by the UV. And as you can see, it's around equator. We have the highest emission, the black one here, and that is due to higher solar radiation. The carbon dioxide is also highest around equator, and what we have scaled here, the 11 to 44%, is due to the UV that had not been published before. So to conclude this story is that we can establish that methane, nitrous oxide and carbon monoxide have been emitted from vegetation. So this is true. But we have very low emission. But as I said in the beginning, we also have plants all over, and we have plants in many layers. So it could be an important source. There are still many unknowns. We have to do some further investigation, of course. But it also means that the window for human action is getting more narrow, because we have this natural source we cannot do much about. Thank you for listening.